Okay, class, today we're talking about something called direct proportion. What a direct proportion is this. It's a proportion where an increase in one quantity means an increase in the other quantity. Or similarly, it could be that a decrease in one quantity means a decrease in the other quantity. That sounded fancy and used a lot of big words. Here's all it means. When one thing goes up, the other thing is also going to go up. If the one thing goes down, then the other thing is also going to go down. So they move together, either down or up together. That's all it means to be in direct proportion. All right, the easiest way is to just look at an example. So, if, for example, Johnny sells hand-carved Justin Bieber dolls at the local mall, and he works for 5 hours and his boss pays him $70. At this same rate, how long would he have to work in order to earn $630? First thing to ask yourself is this a direct proportion? Okay, well, let's think about it. So he works 5 hours and he gets $70. If he works for more hours, is he going to get paid more money or less money? Obviously, he's going to get paid more money for working more hours. It wouldn't make sense for him to get paid less money for working more hours. So, the hours go up, and that means the money goes up. And since they both go up together, then it is a direct proportion, so we're good. Okay. Now, how do we set this up? The way you set up a direct proportion is this. You've got to put the same types of things above and below each other in the proportion. Here's what I mean by that. We know that a proportion is a rate on one side, or a ratio on one side, and a ratio on the other side. Okay? Well, let's look at the numbers that we've got here. First thing we see is 5 hours. Let's just go ahead and put that right here. 5 hours. And what I mean by putting the same thing over the same thing is, since we put hours here, then we're going to put hours below it, too. Okay, we've got to put hours. We don't know how many hours, but it's going to be hours. Okay, we've got to keep hours with hours. Okay, so he works 5 hours, and he makes $70. Okay, well, here's another number for us. But it's not hours, it's dollars. So it doesn't go here. 5 hours means $70. That one goes here, and it's got to go across from the 5 hours, because the 5 hours leads to the $70. Okay. At this rate, how long would he have to work to earn $630? Well, there's another number for us, and once again, it's not hours, it's dollars. So it must be the number that goes here, 630. And we're trying to figure out how long, so how many hours. So the one thing we don't know is how many hours, so we're going to call that x. All right, now look at the proportion that we have. 5 over x equals 70 over 630. Well, we're trying to find x. How do we do that? Yes, that's exactly correct. We cross multiply. When in doubt, cross multiply. That's probably going to get you the answer. Okay? So, x times 70 on this side is going to be 70x. 630 times 5 is something we're going to have to figure out real quick. 630 times 5, 0, 15, 31. So here's what we've got. 3,150 equals 70x. All right? Well, now all we have to do is divide by 70 on both sides. And that should get us our answer. Let's see what we end up with here. Okay? First of all, we've got 0 and 0, so we can cross that out. How many times does 7 go into 31? That would be 4. And how many times does 7 go into 35? That would be 5. So, our answer is x equals 45. How long would he have to work to earn $630? 45 hours. And there we go, we've solved our direct proportion. Okay? Direct proportion is all really just about setting it up, because solving proportions is something that we've already learned how to do. We already know how to do all this stuff, cross multiply and then divide. You guys can do that already. It's all about setting it up, and the key is hours over hours, dollars over dollars, or whatever it is that you're talking about. So let's look at the second example here. Sally's picking up slugs out of the garden to help her mom, because you know slugs are just terrible for gardens, as we all know. If she works for 45 minutes, she finds 20 slugs. If she only works for 10 minutes, how many slugs would we expect her to find? Okay, It's all about setting up the proportion. So the first number we see is right here, 45 minutes. I'm just going to make that my first number. Okay, 45 minutes. So she works for 45 minutes and she finds 20 slugs. Notice I put the slugs over here because if I'd put it here, we would have had minutes with slugs, and we can't have that. It's got to be minutes with minutes, slugs with slugs. Okay, if she only works for 10 minutes, okay, pause, that's our other number. Slugs are minutes, it's minutes. 10 minutes. So she only works for 10 minutes. How many slugs would we expect? How many? We don't know. That's our variable, x. Okay. Well, real quick, let's check and make sure, is this a direct proportion? Okay, let's think about it. 45 minutes and she gets 20 slugs. What if she only works for 10 minutes? So, the minutes, did they go up or down? Well, they went down. She started at 45 minutes, now we're saying only 10 minutes. So, the minutes go down. Well, if she works for less time, is she going to get more or less slugs? You would think she would get less slugs with less time, and more slugs with more time. So, they go up together, they go down together, that means it is a direct proportion. Okay, so we're good in that sense. Alright, now all we have to do is solve it. Now's the easy part. Okay, cross multiply. 10 times 20 is 200. And 45 times x is 45x. Now we just have to divide both sides by 45. And that'll tell us what x is. 45 is going to go into 200, let's say 4 times. Alright, that's 20. That's 18. Subtract, and we're going to get 20. We're going to have to put in a decimal and a 0. Decimal, drop down that 0. 200 again. 45 goes into 200. We already decided 4 times. That's going to give us 180 again. And it's going to repeat forever and ever and ever. So our answer is, we're going to put a little repeating bar on there. We expect her to get 4.4 repeating slugs. Obviously, you can't have 0.4 repeating of a slug, but that's just what we would expect. Okay, that's how we would solve the equation. All right. So that's pretty much the whole concept. Remember, most important thing: you keep minutes with minutes, slugs with slugs, cookies with cookies, grandmothers with grandmothers. Whatever it is that you are talking about, you got to keep the same thing on top that you keep on bottom. Okay. It's going to come in especially important later on when we start talking about inverse proportion. But we will get to that another day. All right, make sure you answer the question in the description, and I will see you all tomorrow.